Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, hey, remember us? Computer America is back and we're so happy that you could join us because here on the show we have, of course, the one, the only Mr. Ralph Bond. He'll be joining us here in just a moment to talk all things. We had a little bit of an extended break. Obviously, as we mentioned before, that he went on vacation, and then he'll tell us what happened next, because what happens next may shock you. But yeah, we'll have Ralph on in just a moment. Everything's well, and everything is getting back into full production because, hey, we're heading into the holidays, and that's usually our busiest, kind of time here on Computer America because, obviously holidays and, everyone starts looking at technology, especially with Black Friday, Cyber Monday, so on and so forth. And then on top of that, you have CES just around the corner. We're already registered for that, and it should be a good show. So with that being said, a lot of stuff in the future that we're working on, but of course, the here and now is of Ralph Bond, and he is our our cyber tech trends. He is our science and technology trends correspondent. There we go. Been a while. Let's shake off the cobwebs, and just before Halloween, we'll shake off the cobwebs. It'll be good. Everyone, welcome back into the program. Ralph, how you doing?
I'm doing okay, much better than a week ago or so. Gosh, yeah, you were alluding to what happened to me. My wife and I went on a wonderful vacation in Alaska for almost 2 weeks, a week and 3/4, roughly speaking. The last 2 days, we were on a wonderful boat ride thing to see the glaciers and all this kind of groovy stuff. Mm-hmm. And my wife got terribly seasick, but it turns out it was more than getting seasick. She actually had COVID. The next day, we went to a local hospital in the area, and they did a test, and they said, oops, your wife's got COVID, and Ralph, you probably have it too, because I was starting to feel a little like a head cold and so forth. So we went back to the hotel room, crashed, and just didn't eat anything, just awful and so forth. And then the next day, believe it or not, we had to drag our behinds down to the airport to come all the way home to Portland, Oregon. But we're on the mend. We're finally on the upswing. And gosh, I guess it's been almost a month since the last time we did a show. So I'm so happy to be back. And we've got a great grab bag of stories for today.
Absolutely. And actually, before we jump back into it, I have to ask you, not to let COVID spoil the whole vacation, how is Alaska holding up? Is it still beautiful?
Oh my gosh, yes. The Denali National Forest, folks. If you've never been to Alaska, I highly recommend it. It's really well worth doing. The scenery is spectacular. These boat trips you can take to go into the fjords or glaciers and all this sort of stuff is just, it's hard to put it into words. We saw a bear, we saw moose, we saw all kinds of wildlife, all kinds of great things. And it was really great. So I recommend it. It was on my bucket list for life to finally see one of the states I haven't seen, and that was Alaska. So I highly recommend it.
Very, very cool. So there you go. Recommends Alaska, does not recommend COVID. So you heard it here first. Ladies and gentlemen, if you're watching the video portion, of course, see myself, you can see Ralph, and you can see the show notes. Show notes are going to be pretty important today because you can see, of course, the source material that we're kind of pulling from, as well as Ralph has included many videos to go along with this. So you can see some of these things in action because, it's one thing to hear about new smart clothing or, something of that nature. It's another thing to see it in action. So computeramerica.com, it's where you'll find the show notes, all the videos, everything that we talk about. It will be included by the time that you hear this. And Ralph, I think with that, let's go ahead and get started.
Yeah, we've got a really big grab bag of fun stories. And again, just to recap slightly, as the correspondent for technology trends and so forth, we look at robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, all across the board. And the first story really has a funny kind of name, Smarty Pants. No, not what my parents used to call me as a child. Smart E, lower E, pants. You will find out what this is all about here. So the headline is U.S. intelligence to spend $22 million on smart electrically powered and networked textile systems. Wow. And this comes from a couple of sources here. First, I got onto this from a story on extremetech.com by Adrianna Nine. And then I went to the source for this story, the organization, which is the IARPA. I have to admit, I'd never heard of them before. So hopefully maybe this will be a revelation for you and the audience as well. So let's get into this story. But first things first, we need a little bit of background on where this research is coming from. So the Intelligence Advanced Research Projects Activity, and of course, we'll mercifully use the acronym IARPA. They're headquartered in McLean, Virginia. Ben, I'd never heard of these people. I mean, not that I should have necessarily, but it's just kind of fascinating when you find out what they're up to. So this organization invests in high-risk, high-payoff research programs to tackle some of the most difficult challenges of the agencies and disciplines in the intelligence community. So this is spooky stuff. This is James Bond kind of stuff.
This is, I guess, the stuff that they, that they want done, but they don't want to like devote an entire department. So it's something that like, that didn't really pay off and we just wasted 2 years. They have this little thing off to the side that's like, if you get it done, great. If not, you tried.
Well, yeah, and it's catalytic research in a sense. It's investment research. So the Intelligence Advanced Research Projects Activity, and again, let's just go with IARPA going forward to make it simple. There is their goal is to push the boundaries of science to develop solutions that empower the intelligence community to do its work better and more efficiently for national security. So the IARPA does not deploy technologies directly to the field. This is what I meant by a catalytic research organization. So their job isn't to develop things and then deploy. No, their stuff is they just develop these things. So instead, they facilitate the transition of research results to their intelligence community customers for operational application. And their areas of interest for the IARPA team includes artificial intelligence, no surprise, quantum computing, machine learning, and this one I thought was interesting, synthetic biology. So in specific, the IARPA is investing in cutting-edge synthetic biology research that will help the intelligence community address biothreats along with other possible applications. Wow. I mean, the scope of the work of these people is amazing.
Yeah. And I can imagine that I'm not buying into any of the conspiracy that COVID was like a bioweapon, but you could see that, you need a response to something that is kind of unknown. So I'm sure after COVID, that last one, synthetic biology, is very important as well.
Yeah, absolutely. So with all of that background about who the IARPA are, who these people are, let's get into the story. Let's get into the news. So the Intelligence Advanced Research Projects Activities Smart ePants, that just makes me laugh. Program seeks to develop clothing with integrated audio, video, and geolocation sensor systems that feature the same stretchability, bendability, washability, and comfort of regular textiles. Let that sink in for a second. That's really something. I mean, we all talk about the body cams that our police forces often have and so on and so forth. Imagine that. What they're saying is imagine that worked in as maybe part of a clothing that's flexible and washable, not a separate hard shell device, right? I mean, wow. So it says, by weaving these devices directly into garments, intelligence community personnel will be able to record information from their environment hands-free without the need to wear, here's the key, without the need to wear uncomfortable, bulky, and rigid devices. This is pretty wild. As a result, personnel will have a greater range of motion, thus improving their response time in challenging circumstances. That's great. So it goes on to say, active smart textile research is a burgeoning field where fabrics are designed to adapt and change their functionality in response to changes to their external environment and or user input. And what I liked about the article too is it kind of gets into a little compare and contrast. So it goes on to say, unlike passive smart textiles, such as Gore-Tex, which rely on their structure to function, active smart textiles employ energy to power built-in sensors and or actuators that sense, store, interpret, and or react to information from their environment. Okay. New enabling research to transfer many of these capabilities of rigid wearable electronics into active smart textiles include, and here's the range of the things they're looking at in this area of smart textiles: weavable conductive polymer wires, energy harvesters powered by the body. We have another story in today's show that's related to this. Ultra low power printable computers on cloth. Wait. Ultra low power printable computers on cloth? Microphones that behave like threads, or microphones that are in fact threads. And I love this one. This last one is great. And scrunchable batteries that can function after many deformations. Scrunchable batteries? Okay.
And you know, just looking at you know, kind of the video portion, you can see there that they have some of these kind of miniaturization. Obviously, you have like a little coin battery, but you know, like in place of buttons, you'd have like a little sensor for a camera that would be woven into a thing. You could have these things that would just be embedded into the shirt or jacket or something like that. Ralph, it kind of makes a lot of sense that, you know, you would want a lot of these devices just built into the clothing. Like, the first thing that kind of jumps to my mind, and I'm sure we're going to get to, you know, some of the uses, but the first thing that jumps to my mind is all the body cams that we're asking all the police officers to kind of go on and wear, you know, just have it built into a jacket, you know, built into their uniform. They don't have to do anything else.
Exactly.
Very cool.
Yeah, exactly. It's fascinating. But of course, again, the mission of this group is for more
intelligence,
reconnaissance,
CIA, FBI,
so it's a
so
little
on.
more, little more cloak and dagger kind of stuff. So going on here, it says, in order to transfer this research into active smart textile products, revolutionary new materials and manufacturing techniques are needed to develop complete and integrated systems containing mechanically deformable and durable items such as power sources, sensors, computation and data storage, and electrically conductive system component wires and interconnects. So this is a very, very daunting task that they put themselves to. And then it says here, the Intelligence Advanced Research Project's activities, Smart ePants, goal is to build sensor systems that are comfortably integrated into primary clothing, including shirts, pants, socks, and underwear. How about that? Smart socks, smart underpants, or aware or data gathering underwear. I love it. Research committed to developing these systems will be divided into 3 demonstration tracks: audio recording, video and photography capture, indoor geolocation. And for more, please check out the articles with the links in today's show notes, because we've just kind of thrown a stone over the water and skipped through a little of the points here, but there's so much more research, so much information, especially if you go to the research organization's website itself. It's just a treasure trove of information, not only about this story, but many other things these guys and gals are up to.
You know, and I'm not saying that all the research is made available in public like that. And the article that you linked to does give a very important, you know, kind of counterpoint to all this. That
yes, that's true.
You know, it's kind of negative to the implications of, you know, more secretive, more built-in, and more ubiquitous surveillance and law enforcement and things like that. Which again is an important, you know, kind of thing to consider. But Ralph, I always, you know, try to remind people that, you know, technology really doesn't care that, you know, your ethics or morals or whatever. If we can develop it, someone else out there is also working on it, also trying to miniaturize and do it. Like, if nothing else, for a good preventative measure, to know what the possibilities are, to know what to look for, to know how these things work. That way you're not caught off guard when it's used against you. I'm not saying that this should be, you know, woven into everyone's socks so that everyone can track everyone indoors at all times. But just knowing that, Ralph, our law enforcement doesn't come up on someone and they have a pair of socks that are glowing and like radiating energy, and you're like, what are these crazy socks? Like, you know, we might have an idea of knowing what to look for as well. So, you know, it's kind of being proactive in how far technology can go. And really, the fact that they're publishing it and letting everyone know is, again, another I think, kind of positive, so that even the public is not caught off guard when smarty pants are walking around everywhere, you know?
Right. Yeah, you're right. It is kind of a double-edged sword. On one hand, it's obviously very helpful for the intelligence community, but in the wrong hands, it could be used for devious spying purposes on your friends, neighbors, whatever. I get that. It sort of reminds me, Ben, of the whole discussion about artificial intelligence these days. You and I know from the stories we've brought to the audience many, many times over and over again about the great, glorious, wonderful things that artificial intelligence is doing in medical research and so many other fields. And yet the mainstream press, I get it, goes to the sensational, to the scary, to the spooky parts of AI. So this story kind of feels like something similar. I think the positives I hope will ultimately outweigh the negatives.
Yeah, and I know that AI has really hit the mainstream because my father-in-law said to me, "Hey Ben, how about that AI?" This is a guy that is not technically which is weird because he ran like Dallas County servers back in 1980. He's the one who set up the whole thing. And then after that, he just stepped away from technology. He's like, I'm not really into that anymore. But still, he's not very techno savvy, but he's like, AI, isn't that crazy? So AI has definitely hit the mainstream. And like you said, because of the sensationalization of it, either way, it's definitely good. I think hearing about this kind of research is good. The more that we know, the more we can advance it. That's all. Ladies and gentlemen, today's supposed to be about good, and I promise all of these things have a good side. It really is positive to hear about these things. This little graphic that you have here built into the show notes, goes to show it's not just for Cloak and Dagger and, CIA, FBI, so on and so forth.
Hey, you're right.
But it's sports performance, medical, communication, stuff that may one day soon help you individually.
Yes.
Like, imagine if it were built into, a shirt that Ralph was wearing, and then it could tell before he could that his body temperature was rising due to an infection of some sort. I'm not going to say what it could be.
Wow.
But hey, maybe it could be like, you're starting to show early signs before maybe even Ralph notices. So there's positives. I promise.
That's a great point.
Yeah. Story number one. Story number two. Let's go ahead and keep with the cloth. And this is very, very cool, and it really speaks to your area of expertise as well when it comes to buildings and design and interesting stuff. Because boxes are fun, but other kinds of construction are even more fun. So story number two.
Right. Well, story number two speaks to, as Ben was alluding, my last 10 years of activity in the professional community was to work for Autodesk, and in specific the architecture, engineering, and construction division of Autodesk. And so in that 10-year period of time, I got to learn all about building information modeling and technologies that are involved in the building community, the structures, infrastructure, plus built high rises, homes, towers, you name it, all this kind of stuff. So this story really caught my attention. The headline here is Scientists Knit, like knitting needles, scientists knit futuristic eco-building designs using fungal networks. Okay, you can't resist that headline. This comes from an outlet called Frontiers Science News, a story by Angharad, Brewer, Gillham. And of course, as we have pictures, we have links, all this kind of stuff in the show notes, folks. Come out to computeramerica.com and sure check that out. So here's the story. Scientists at England's Newcastle University are hoping to reduce the environmental impact of the construction industry. This is a big goal these days in the world of architecture, engineering, and construction. So with this goal in mind, they have developed a way to grow building materials using knitted molds and a root network of fungi. What? Okay. Although researchers have experimented with similar composites before, this is true, the shape and growth constraints of the organic material have made it hard to develop diverse applications that could fulfill its potential. So again, they're saying working with fungi and so forth, and other out of natural materials that are complete contrast to concrete and other things that we typically think of for building, not new. But these guys have kind of got a new twist. They've solved a problem in the equation, so to speak. So going on here, it says using the knitted molds as a flexible framework, or the researchers call a form work, the scientists created a composite they call mycocrete, which is stronger and more versatile in terms of shape and form, allowing the scientists at England's Newcastle University to grow, here's the key, to grow lightweight and relatively eco-friendly construction materials. So, and again, come to the show notes. The picture's amazing. It's this really wild looking stuff, very organic. It looks like sci-fi movie stuff, or it looks like something, when the aliens come to Earth and they build something, it kind of looks like that.
Because it's also, kind of natural and kind of fungus and, kind of derived. It also has kind of that like fantasy dark crystal, like essentially,
yes,
it's half nature, half like kind of magical because you don't really see mushrooms that are just according to this image. I'm assuming they are regular sized people that they built a structure that's probably about 5 feet tall. It's like a little shaped hut. It's very, very cool.
It's very interesting, very curious stuff. So going on with the article, it says Dr. Jane Scott of Newcastle University noted, quote, "Our ambition is to transform the look, feel, and well-being," interesting, "of architectural spaces using mycelium in combination with bio-based materials such as wool, sawdust, and cellulose." So they're looking at this mushroom, as it were, base material ingredient, but combining it with wool, sawdust, and cellulose, all renewable, relatively speaking, materials. So wait a minute, time out. What is or are mycelium? Well, it's the vegetative part of a fungus consisting of a network of fine white filaments. That's the ingredient they're talking about in this research. To make composites using mycelium, part of the root network of fungi, the scientists mixed mycelium spores with grains they can feed on and material that they can grow on. That's the forms, the knitted forms they're talking about. So this mixture is packed into a mold and placed in a dark, humid, and warm environment so that the mycelium can grow, binding the substrate tightly together. And once it's reached the right density in this growth process, and before it starts to produce the fruiting bodies we call mushrooms, so the mushrooms we see are actually the fruit, the output of the mycelium network, okay? So once it's reached the right density and before it starts to produce the fruiting bodies we call mushrooms, it is dried out. That material is dried out. And this process isn't that wild?
That is such a great, and again, just to reiterate that process. So they mix wool, where is it? Wool, sawdust, and cellulose along with the mycelium. They essentially grow the mycelium, like they are growing mushrooms.
Yeah.
And then once it's dense enough, or once it's the right density, they take it out, dry it, and then they can use it as essentially branches and sticks is what it looks like from the image. But that'll be the scaffolding. That's crazy that they actually grow this stuff. Like
weird.
Like Rob, I thought they were just gonna like grind up the mycelium and kind of blend it together and then extrude,
make
the
bricks
kind of mold
or whatever.
But they actually grew this stuff. That's fun.
That's right. I know. It's really fun. And again, I want to stress once again, if you're listening to us on one of the podcast audio outlets, great. Please, though, come to computeramerica.com, get the show notes so you can see the picture of what Ben and I are talking about. Get the links and learn more about this, because really so much of what we talk about is so visual. It's really, you don't want to miss out. So this process could provide, as we said before, a cheap, sustainable replacement for foam, timber, and plastic. But here's the challenge. Mycelium needs oxygen to grow, which contains the size and shape of conventional rigid molds and limits current applications. That was the problem. But with this challenge in mind, England's Newcastle University team says knitted textiles offer a possible solution to that limitation heretofore. They have developed oxygen permeable molds that could change from flexible to stiff with the growth of the mycelium. Dr. Scott and her colleagues set out to design a mycelium mixture and a production system that could exploit the potential of knitted forms. So people were messing around with the idea of mycelium and other natural ingredients to create building materials and building structures in the past. That was not new. But the problem was, because of the need for the oxygen and other issues like this, there were really severe limits on what you could do with this. And these folks, Dr. Scott and crew, think they've, kind of provided a solution to this potentially. As Dr. Scott notes, quote, knitting is an incredibly versatile 3D manufacturing system. It is lightweight, flexible, and formable. The major advantage of knitting technology compared to other textile processes is the ability to knit 3D structures and forms with no seams and no waste. So again, we're just giving you the highlights. You want to learn more about this? Come and get the links at the show notes and dig in deep. It's a really wild stuff.
Yeah, and I'm kind of thinking of past mycelium kind of products that we've talked about here on the show, and I know that we've covered one that they were using mycelium to essentially make bricks, so that you could build bricks and build a house or whatever you would do with a brick. And I guess, Ralph, that they're saying that the reason that you can't really expand that is because, to grow them any larger, I guess like the mycelium in the middle wouldn't have enough oxygen. It's not permeable. You couldn't get it to grow and be sufficiently sound, I guess. So this is a completely different way. Obviously, they show this off by building a type of tent. Which Ralph, I'm thinking might actually be one of the best early uses of this thing, because I don't know if anyone out there, and as you can tell, I go outside all the time. I am an outdoors but I hear that when there are events like music concerts that are multi-night or whatever, there's campgrounds. It's not uncommon, Ralph, which is news to me. People go and buy a tent and then leave it at the campsite and just trash it. It's like a one-time use tent for them.
Terrible.
Music concerts and so on and so forth. Like they'll be littered everywhere. I could imagine that for something that could be temporary but very structurally sound, and hopefully biodegradable, which it sounds like this would be biodegradable as well. And let's see, the term that they used was relatively eco-friendly, was at the beginning of the article. I don't know what relatively eco-friendly means, but still, I could see an application, Ralph, where, kind of limited short-term structures being replaced by, maybe something like this.
Could be. And Ben, I'm also reminded of something talking about mycelium, again, the kind of white fibrous root networks of mushrooms. Okay. Remember, I don't know, maybe a year ago or something, we did a story about a company that was developing using mycelium, using mushroom material and a forming and a drying process, kind of sort of not too dissimilar for what we're talking about here, to make a replacement for leather for upholstery or auto upholstery purposes. Maybe that rings a bell. We might remember that story. So there's a lot of research and a lot of interest in good old mushroom root networks, aka mycelium. Go figure that. It's just fascinating.
I remember, and I believe they're called Milo, as in like mycelium, but Milo. They were partnering with a lot of high-end fashion brands.
There you go.
And they're able to make these rolls kind of.
Right.
I guess they called it unleather
sheets. Yeah, the sheets that you can use to whatever, shoes, whatever you want to do. That's a replacement for leather, so that's pretty cool.
There's lots of good research into mushrooms, and thank you for reminding me of that one, because that one is
that's a fun story.
That one was a lot of fun, and of course the images say 1,000 words. So story number 2, story number 3. And finally, this is very much the Matrix. Although, what we kind of and what I love about communities, Ralph, is that they'll like the Matrix community. They'll look at something like a premise of a movie, and to us, it's just a fun movie. You just go look. They analyze everything, and they're like, humans are some of the worst batteries you could possibly create. Put babies in a little growth vats, and use them as batteries to power the whole Matrix universe, which may be true. But story number 3 has a little bit lighter of a touch and a much better application than the Matrix. So story number 3.
Yes. Story number 3. So the headline here is humans as batteries. Future smart devices could use our bodies as a power source. Now, right away, you're going to find out it's a pretty contained or small level usage model. So let's not get too excited, but it's still very interesting. This comes from the Science Times, a story by Conelisa, Habilla. And again, we have the link and the pictures and all that kind of good stuff in the show notes. So here we go. Smart devices could soon tap their users as a power source by converting mechanical energy of the movement of the body into electrical energy. Scottish researchers at a firm called Integrated Graphene may have figured out how to tap body movements to generate electricity. So mechanical energy is one of the most abundant sources of energy in nature. And the daily actions of humans can generate a small, here's the truth in lending statement here, can generate a small amount of electrical power. However, most of our mechanical energy is wasted in the environment, waiting to be converted into more valuable forms. New technology is being developed where super thin matting placed on floors can capture the energy of each step. And whoop, whoop, ting, ding, ding, time out. Need to have a little reminder about a previous show where we had something kind of sort of related to this. So a side note here, I wanted to say this as an aside, as part of our August 25 podcast, we talked about a UK tech company called PaveGen, P-A-V-E-G-E-N, that has invented a way to generate renewable energy from people's footsteps on floor surfaces, okay? So this is kind of sort of semi-related. Integrated Graphenes, the company we're talking about today, their idea is closely related to PaveGen's basic concepts. Now, the integrated graphene team calls for the energy collected from walking around the house, or I would say any other structure, to be stored to power household items. So their ideas are really kind of fun, sort of focused on the home initially. Mm-hmm. And the idea is if we could put something in our flooring that would generate electricity from our walking about, and then store that energy to power household items, this could be an interesting way of reducing your draw on the grid. So, however, it has become a challenge to make this possible using traditional triboelectric nanogenerators on a commercially viable scale due to limited energy output, low durability, and inefficiency. Okay, time out. Side note.
Triboelectric nanogenerator. Yes, that's a word.
Well, yeah, we need to, that's a mouthful, isn't it? And we need to kind of do a side here for a moment to kind of introduce that. So as a side note, again, in August 25 podcast, news about PaveGen, the other company, a triboelectric nanogenerator. This is an energy harvesting device that converts mechanical energy into electricity using the triboelectric effect. Okay, the triboelectric effect describes electric charge transferred between two objects when they contact or slide against each other. It can occur with different materials, such as the sole of a shoe on a carpet, or between two pieces of the same material. So PaveGen, we talked about their tiles that they created for crosswalks, shopping malls, all this sort of stuff where when you walk, the triboelectric effect would generate energy, okay? These guys are doing, the integrated graphene team are doing something similar, but even more slick, more thin, more elegant, if you want to call it that. So, okay, with all of that said, finally, here's the news. Tech company Integrated Graphene claims to have developed a graphene-based product that can help solve this problem, meaning the limitations of triboelectric nanogenerators developed to date, such as the solutions from PaveGen that we talked about in August. Integrated Graphene has developed an innovative 3D graphene foam called GII, which offers potential as an active layer in a triboelectric nanogenerator. If you wanted to go back to August 25 and look at our show notes and all this sort of stuff and learn more about PaveGen, you'll see PaveGen was very cool, very groovy, but they were like tiles, kind of thick tiles and so forth. These guys are talking about an innovative 3D graphene foam called G, which offers the potential as an active layer in a triboelectric nanogenerator.
Yeah,
wow.
So for everyone watching the video portion as well, that image there is of a person stepping onto the triboelectric nanogenerator. These three pucks that are on each side of the triangle, kind of go down, and when they make contact, they produce that electricity. And then, of course, this is this is their capacitor, but this is essentially the G. And you can see that it's almost like a business card.
There you go.
In terms of I should say like a credit card in thickness. It's very, very thin and does the same thing. Yeah.
Yeah, so that's the point, and I'm so glad you brought those images up for the audience that's being able to view us, because again, you can see the PaveGen solution, great as it is, had some beefy hardware, if you want to call it that.
Mm-hmm.
Whereas these guys, integrated graphene's approach does the same basic thing. Now, it may not generate as much energy, let's be fair, as the PaveGen solution, but nonetheless, what a fascinating condensation, if you want to call it, or miniaturization, or whatever the right word is. I just think it's amazing. So going on, it says experts from the University of West of Scotland's Institute of Thin Films, Sensors and Imaging, talk about a geeky bunch, conducted a study focusing on the potential of integrated graphene's 3D graphene foam as a power source for autonomous sensors. The research team aims to transform the mechanical energy of humans wasted in nature into a more helpful form of electrical energy. The result of the study, again, the study at the University of West of Scotland's Institute of Thin Film, Sensors and Imaging. So the result of their study reveals that the force of a human footprint exerted on the pressure-sensitive mat containing integrated graphene's G triboelectric nanogenerator sensors can generate enough energy to drive monitoring devices to identify people who enter or leave a room. I'm sure there's many other applications, but this is what they're particularly interested in. So this can be used as a low-cost, energy-efficient approach to monitor occupancy of a structure. In addition, the mats made using this G material, this foam, the mats can also help optimize energy resources like controlling room temperature upon a person's entrance or exit. Researchers believe this can be useful in schools and universities that need to connect room occupancy to a ventilating system and CO2 monitoring. And of course, it's more than schools and universities. This just happens to be what they're interested in first pass, but this could have applications even in your own home for that matter, folks, or commercial buildings or office buildings. Can you imagine? I mean, and again, a foam that does this triboelectric function that can be contained, as Ben was saying, in a kind of a form factor that looks as thin as a credit card. My God, this is just great stuff.
Very, very thin, and room, really room occupancy. Like not even turning mechanical energy into electrical energy, but Ralph, like, imagine these being your floor sensors. So instead of having like motion sensors that could like trip or what have you, just having these kind of embedded in flooring. And then, we're in the age of smart appliances and smart lighting and stuff like that. Having the lights come on automatically because it knows that, hey, you're generating electricity from your feet and it knows what room you're in, or the air conditioning or so on and so forth. Everything just gets a little bit more efficient without having to do motion sensors and cameras all over your house. This is just built in. So there's a lot to love there, and of course, the integrated graphene website has a lot of other promise for increasing battery life and so on and so forth. Ralph, graphene has so many promises which we've heard over the years, and it's even though it's slow, 10, 15 years ago, we even heard about it in the lab and how it was going to revolutionize batteries. It was going to do this, that, or the other. At least, Ralph, we're gone from like in a laboratory, it increases X by Y. That those used to be the stories. Now we're hearing stories of here are products that may one day make it into your home. So we're getting closer. We're not there yet, but graphene is making itself known. So that's good. That's definitely good. Story number 3, story number 4. Let's go ahead and end with a little bit of medical news. And well, hey, this one is, really strange. Like cancer is bad. I don't feel bad about saying that. Cancer is bad. And when we talk about cancer so often on the show, we talk about killing it, really ending the cancer cells and ending the process. And, that's our cure for cancer, is to get rid of it. The story you found, Ralph, I am flabbergasted because I have never heard of an approach like this. So let's hear about story number 4.
Oh, yeah, me too. I just, and again, a lot of times, folks, what I do, because of my personal interest in medical research and so forth, very frequently, most of the time, the last story we do on our weekly show here is medical research oriented, and this fits that bill. So the headline here is aggressive cancer cells transformed into healthy muscle cells. What? It's not just kill the cancer, it's transforming. That headline alone just said, whoa,
It's strange.
what?
It's strange.
It's fascinating. Okay, so a couple of sources for this. Cold Spring Harbor Laboratory articles, one source. And sciencealert.com, a story by Michelle Starr, was another source for this story. I've got the links and so forth and imagery and everything you need right in the show notes. But let's get into this. So the Cold Spring Harbor Laboratory scientists, Christopher Vaycock and Martina Sroka, Sroka, these two have found a way to morph cancerous rhabdomyosarcoma, boy, that's a toughie, rhabdomyosarcoma cells into muscle cells. So they figured out a way to take this cancerous stuff and transform it into muscle cells, not just kill it, but transform it. How interesting is that? As the cells transform, they take on typical muscle features, including the spindle-like shape shown in the article's image. So you need to see the article to see what we're talking about. Okay, wait a minute. Time out. What is the Cold Spring Harbor Lab? Founded in 1890, Cold Spring Harbor Laboratory in New York State has shaped contemporary biomedical research and education with programs in cancer, neuroscience, plant biology, and quantitative biology. And get this, Ben, I didn't even know about these guys, the Cold Spring Harbor Lab. Check this out. They're the home to 8 Nobel Prize winners. The private but not for profit laboratory is private but not for profit. You got to love that. Get a load of this. Employs 1,000 people, including 600 scientists, students, and technicians. Whoa, okay.
That's a lot of brain power.
Oh my gosh, no kidding. What are the rhabdomyosarcoma cells? What are they? Well, they're usually just referred to as RMS. So that's what we're going to do just for the sake of not getting tongue-tied. And it's a type of sarcoma. And sarcoma is a cancer of soft tissue such as muscle, connective tissue such as tendon or cartilage, or bone. So RMS, the disease in question, usually begins in muscles that are attached to bones that help the body move, but it may begin in many places in the body. And there's a source for that information as well if you want to learn more. So a devastating and aggressive type of pediatric cancer, RMS, resembles children's muscle cells. Because of this close resemblance, no one knew whether this proposed treatment method called differentiation therapy might ever work in RMS. It could still be decades out. But now, thanks to Vaycock's Cold Spring Harbor Lab team, it seems like a real possibility. And it's always amazing to me. This is such a profound story, and yet, you don't hear this on regular mainstream TV because they're so inundated with problems and, world politics or God knows whatever. But anyway, here we go. For 6 years, the lab has been on a mission to transform sarcoma cells into regularly functioning tissue cells. So what I want to stress again, folks, we're not talking about radiation or treatment that kills cancer cells, transforming them into regularly functioning okay tissue cells. That's just the part that just made my brain go, wow. So as noted a moment ago, sarcomas are cancers that form in connective tissues like muscle. Treatment often involves chemotherapy, surgery, and radiation traditionally, right? Procedures that are especially tough on kids. Oh, God, of course. If doctors could transform cancer cells into healthy cells, it would offer patients a whole new treatment option, one that could spare them and their families a great deal of pain and suffering. Well, of course, to carry out their mission, Vaycock and his team created a new genetic screening technique. Using genome editing technology, they hunted down genes that, when disrupted, would force RMS cells to become muscle cells. Ben, I can't stress enough the bizarre idea of transforming cancerous bad cells, but turning them into okay cells.
It's really, like I said from the outset, when we talk about curing cancer, it's about ending the cells, killing the cells. This is flipping that switch back the other way, and which I never thought of. Yeah.
I know. This is what really made me think this story is so profound in its implications that it should have, in my opinion, warranted international headline news, but it is what it is. So to finish things up here, a little bit of, kind of details. That's when a protein called NF-Y emerged. With NF-Y impaired, the scientists witnessed an astonishing transformation of RMS cells, the cancer cells, into healthy muscle cells. Folks, we've just again given you the skipping stone over the surface of this story. There's so much more you can learn. Come out to computeramerica.com, get today's show notes, check it out. It's just, I think, one of the most profound stories about transforming cancer cells into healthy tissue. What?
There's and to kind of let everyone know, like when we talk about some of these technologies and their profound effects, Ralph, when they say gene editing, that just reads to me as CRISPR. CRISPR is a technology relatively new. Maybe in the past, less than 10 years, we've been able to really tap into it. And CRISPR is going to lead to a lot of these things. It's, being able to go in there and change genes, edit genes at that level, kind of targeted. Yeah. So, amazing technology and amazing application of that technology to turn those cells. I'm guessing, Ralph, that they're only turning the cells, at least so far. Obviously, this is very basic research, that were originally muscle cells back into muscle cells, or I should say, should be muscle cells, because you probably don't want muscle cells in your bones for all I know. I'm not really an expert on that. Yeah. But to be able to reverse the effects of cancer, even to some extent, is just
remarkable
and profound, like you said. So that's a great story to kind of wrap it up on. But hey, if you're checking out the show notes, if you're reading along, you have some more stories down there. What are these other stories that they can check out?
Yes. So one of the things we've started doing the last several shows is sort of honorable mention stories that we just don't have time to cover, but I just want to have the audience know about and have access to. And we won't go into details here, but a headline is zinc air batteries might be cheaper and safer than lithium ion. And the source comes from Inside Electronic Vehicles Global, which is an interesting outlet. There's all about that technology. Check it out. The show notes will give you the link and you can learn about it. Here's another one that I thought was interesting. 90% reduction. Scientists discover natural molecule that eradicates plaques and cavities. So here's some technology for the dental world. How about that, huh? So we've got links to that as well. And please come out to computeramerica.com. Get today's show notes. It'll have all of this information and you can dive deeper. And if you're listening to this as a podcast, please also come out because you can then see the images, get the links and all that good stuff.
Perfect. Yeah, and I couldn't agree more. The honorable mentions could be stories themselves. Ladies and gentlemen, we want to again say thank you for joining us and thank you for continuing on, because we just had a bit of a break. Like Ralph said, it's been about a month. We've had some shows in the interim, but in the meantime, we'll be back hopefully every single Friday, and we have some things that we can do on the back end to make sure that, hey, every Friday coming up, especially during the holidays, we have a show recorded, at least pre-recorded to have playing on every Friday. So we'll work on that. But Ralph, it's good to have you back. I'm glad that you and your wife are doing better on the mend, like you said. And ladies and gentlemen, thank you so much for tuning in to Computer America. We'll catch you here next time. Until then, everyone have a great day. Thank you so much. Bye-bye, everyone.